Hello everyone, it's me Gagan Kumar present over here to teach you physics. Let's move on to the video. Today we will be discussing units and measurement lecture number 5. So in this lecture we will be discussing dimensions and SI unity of some physical quantities. Okay. So in the last lecture already we have completed 35 physical quantities, its SI unity and its dimensional formula also. Now in this lecture also we will be seeing some more physical quantities, its SI unity and its dimensions also. Okay. Now move on to the topic. In the last lecture we discussed number 35, that is velocity gradient. What is this? Velocity gradient. So remember always, whenever gradient word comes and here one physical quantity is there, velocity gradient, then what will you have to do? Now your formula should be velocity should be up and some length will be in the down, so it will be V by L. So velocity gradient. So last class you understand this one. So this unit is nothing but it is coming how much? It is coming second to the power minus 1, or dimension if you will write t to the power minus 1. So this one we studied in the last lecture. Now today we will be discussing number 36. We will be discussing temperature gradient. Temperature gradient. If I am telling about temperature gradient, then what is this one? Now here same thing. So it will be temperature by length. Temperature by length. So temperature is basically Kelvin. So unit will be Kelvin, and here length unit is meter. So it will be Kelvin by meter. So this will be SI unity, and here you can write this one as nothing but m0 L to the power minus 1 t to the power 0 k to the power 1. So you can write like this also, or only L to the power minus 1 k to the power 1 also you can write. Okay. So because it is coming Kelvin by meter, so it will be meter will go up, it will become meter inverse, or L to the power minus 1 you can tell. Now understand next quantity 37. Suppose I am telling coefficient of viscosity. Coefficient of viscosity. The symbol is basically given as eta. Coefficient of viscosity. So what is this one? Now this eta is nothing but this formula will be tangential stress divided by velocity gradient. Velocity gradient. Just now you understand what is velocity gradient. Okay. So not only velocity gradient, if any gradient word coming and your physical quantities there, temperature or velocity, it will be velocity by length or temperature by length when gradient word is there. Now if you want to understand coefficient of viscosity, tangential stress by velocity gradient, or you can write it is eta equal to force by area divided by velocity gradient. I can write as V by I can write as x, or V by L, or delta V by delta x, or delta V by delta z. Okay, so z is basically length only. Okay, change in length you can write. So if we will modify this one, it is F by A delta z by delta V. Okay, so that means it is a length by velocity, that's all. Now here if I want to write the unit from here, SI unit I want to write, then what will be SI unit of eta? So SI unit of eta, that is nothing but, so here force unit is Newton and area unit is basically meter square. So because stress is basically force by area, it is Newton by meter square into delta z is what? Now that is your length unity, that is meter unity. Okay, you can write your length unit delta L, or you can write delta z or delta x. Okay, this all represents basically change in length. Now here you can write meter by second. Now here if you modify this expression little, then how much you will get? Definitely meter will get cancelled, second will go off. You can write Newton into second by meter square, or Newton already you know, so I can write here. So Newton is nothing but that is kg meter into second to the power minus 2 into second divided by meter square. Now here if you calculate this one here, definitely this meter will cancel to meter square, and second to the power minus 2 into second, it will come second to the power minus 1. So it will become how much? Kg second to the power minus 1 divided by meter. Okay. Or you can write this one as what? Kg meter inverse second to the power inverse. So this one also you can write. Okay. So what is the coefficient of viscosity SI unity? Now Kg meter inverse second to the power minus 1 or inverse, or this one is called also, this is also called as decapoise. This SI unit is also called as decapoise. Okay. Now similarly also from here you can tell what is CGS unity. Okay. So here you can write what is CGS unity of eta. Now CGS unity of coefficient of viscosity is nothing but how much? From here I can directly write. So kg will become gram, meter will become centimeter, and second will become second only, and here as power is minus 1 is there, you can put minus 1. Okay. So here CGS unit of eta is nothing but this much, or this one is also called as poise. This one also called as poise, but SI unit is called basically decapoise. Deca means 10. So it is 10 poise, it is only poise. Okay. Now here if you want to write dimensional formula for coefficient of viscosity, then what will be dimensional formula of coefficient of viscosity? Now dimensional formula for coefficient of viscosity is nothing but, you see, it is coming kg, that means mass to the power 1. So I can write m to the power 1, then here it is L to the power minus 1 because meter to the power minus 1, then T to the power minus 1. So this is your coefficient of viscosity dimensional formula, or you can write it is m1 L minus 1 and T minus 1. Okay. So again I am writing here also. So coefficient of viscosity dimension is m1 L minus 1 T minus 1. So remember directly, then so that you can give answer if direct question coming. Otherwise you can remember coefficient of viscosity is nothing but tangential stress by velocity gradient. So you can calculate and you can get also dimension. And about this decapoise, poise, remember sometimes question also comes, what is the value of SI unit of eta divided by CGS unit of eta. So SI unit of eta is basically decapoise, and here it is poise. So decapoise by poise will come basically what? Only 10. Okay, because decapoise 10 poise divided by poise, so it will come 10 only. So this type of things remember. Otherwise how to convert this also you can understand in the further lectures. Now here this is the coefficient of viscosity. Okay. Now I hope you understand. Now I will go to the next quantity, that is your surface tension. Surface tension. Okay. So what is the surface tension? Now the symbol can be given as a T or you can give S. Surface tension symbol you can give T or S. Okay. Now what is this one? Now here this is called basically surface tension T or S is nothing but that is force by length. Force by length. Okay. So here when we will study fluid dynamics, that time we will study about basically surface tension and all. So here force by length, and here if you want to find SI unity, then it will be Newton by meter, or you can write as Newton into meter inverse. Newton into meter inverse. Now I want to convert in terms of kg and all, then it will be written as kg meter second to the power minus 2 into meter inverse. I will check this one. So this will come how much? Now this will give me kg second to the power minus 2. Okay. So here this is your SI unit of surface tension, and if you want to write CGS unity, kg will become gram, second will be like that only. So gram into second to the power minus 2. Now here if you want to write of tension, surface tension, then it will be m to the power 1 L to the power 0 T to the power minus 2. Okay, or you can write also m1 T to the power minus 2 L1. Like this we can study there are many quantities and its SI unity, and also you can understand about some CGS unity. Then after you can understand also what is your dimension. But for everything remember, whenever calculating dimension of a physical quantity, you must focus on the formula first. So from formula you are coming to SI unity, from SI unity then after you can come to what? Now here dimension. So dimensional formula you can calculate. Now I will go to the next quantity 39. Heat capacity. Heat capacity. Okay. So heat capacity, what is this one basically? Now here you can write this as S. S is nothing but heat by change in temperature. So heat capacity is nothing but heat by temperature, or you can write this one, heat means unit will be definitely joule. Remember, work or energy, that all units are same, that is basically joule unity. So SI unit will be joule by Kelvin or joule per Kelvin you can tell, or you can write joule per Kelvin. So this is your nothing but heat capacity. Now if I will convert in terms of kg and all, so what I can write? In place of joule I can write kg meter square second to the power minus 2 divided by Kelvin. Okay. So here I can write this one as nothing but kg meter square second to the power minus 2 k to the power minus 1. Okay. Now if I want to write what is the dimensional formula of specific heat or heat capacity. Dimensional formula of heat capacity, it will be m to the power 1, L to the power 2, T to the power minus 2, K to the power minus 1. So this will be dimensional formula for the heat capacity. Now I will go to next, that is called specific heat. Specific heat. Now the symbol you can give as small c, and here the c is nothing but how much? Now the small c, and the small c is nothing but that is your heat by temperature, but per unity mass, per unity mass. Remember here. So this is heat basically, this is the change in temperature, and this is the mass per unit mass. Okay, how much heat require to raise the temperature by 1 degree centigrade of a substance, that is called basically specific heat of that substance. So here if this one I want to understand, so it is basically joule divided by kg into this temperature difference is nothing but Kelvin. Okay. So already I told you, whenever a physical quantity and its change is there, so both will be having same unity, like temperature unit is Kelvin and a change in temperature also Kelvin. Okay. So length unit is meter, so change in length also that unit will be meter. Now here you see, if you write this one, how much I can write? Joule will be kg meter square second to the power minus 2 divided by kg Kelvin. Now here definitely kg will get cancel. Now how much you will get? You will get here meter square second to the power minus 2 Kelvin to the power minus 1. Okay. Or if I want to write the dimension of specific heat, so that is nothing but that is your m to the power 0, L to the power 2, T to the power minus 2, K to the power minus 1. So this is the dimension of specific heat. Okay. Now I will go to the next quantity. Now 41. So here we will understand molar specific heat. Molar specific heat. So here when molar specific heat you are telling, that time what in it is you write capital C, and this capital C is nothing but delta Q by N into delta T. Okay. N is basically number of mole. Okay. So here what? Now how much heat required to increase temperature by 1 degree for 1 mole of the substance is called basically molar specific heat. And here if unit will check, this is your joule, heat unit will be joule and mole unit will be mole only, and here this will be Kelvin. So you can write this one also kg meter square second to the power minus 2 divided by mole into Kelvin. So now if you modify this expression, you can write as kg meter square second to the power minus 2 k to the power minus 1 mole to the power minus 1, or you can write dimension of this specific molar specific heat, then it will be m to the power 1 L to the power 2 T to the power minus 2 K to the power minus 1 mole to the power minus 1. So this will be the dimension of molar specific heat. Okay, so I hope you are understanding. So simple formula. So whenever molar specific heat you are telling, for unit mole you need to include here, and that unit will be basically mole. Okay. Now here let me go for the next quantity 42. So what is this alpha? Now this alpha is nothing but that is change in length by original length into change in temperature. So here SI unit if I want to write, so what I can write? Now length unit is meter, change in length also unit meter. So meter will get cancelled. Here you will have only Kelvin. Okay. So here I can write this one as nothing but 1 by Kelvin or Kelvin inverse. Okay. Or I can write as K to the power minus 1. Okay. So same dimension also if I write the same thing will come. So alpha dimension is nothing but M0 L0 T0 K to the power minus 1. Okay. Remember, temperature coefficient of linear expansion is taken as alpha. Similarly, here in 2D, this is in 1D basically. So linear you are telling 1D. So when 2D picture will take, that time will define basically temperature coefficient as beta, and when we will take 3D picture like a sphere or cube like that time you have to define as gamma. So temperature coefficient of volume expansion, that is gamma. So all will having same unity, that is Kelvin inverse. Okay, or K to the power minus 1, dimension also same, because for other cases also it is here it will come basically change in area by original area or change in volume by original volume. So that is why this will get cancel this unity, you will have only temperature difference unity in the down. Degree centigrade is not SI unity, so Kelvin is SI unity. So you must remember this. If a question sometimes given in degree centigrade, you can understand, you can apply the formula also. But remember one more thing, sometimes in question they are asking directly, they will ask what is your alpha in NEET question, and delta L will be given, change in length will be given, original length also given, temperature difference also given. So directly they will ask what is your alpha. If you remember formula itself, directly you can put the answer, okay, from this formula. I will go to the next quantity. So you will go to latent heat. Latent heat. So latent heat symbol is basically given as L. So that is nothing but that is your heat per unity mass, or you can write basically it is your joule divided by kg. And already you know joule is nothing but kg meter square second to the power minus 2 divided by kg. So this will give you SI unit how much? Meter square second to the power minus. Now you want to write the dimension of the latent heat. So what will be it is m to the power 0 L to the power 2 T to the power minus 2. So this is the latent heat of a substance. So now 44 if you will go here, I can go to constant, that is called basically universal gas constant. So what is universal gas constant? Now that is basically R. So R can be written as PV by NT. Okay, so you know PV equal to nRT, that is ideal gas equation. So here basically you can call it is universal gas constant, that is capital R. Now PV is basically represents what? Now pressure into volume, or that is basically work or energy you can tell. So this will give energy basically unity joule divided by N unit is nothing but mole, and T unit is nothing but that is your Kelvin. Now here you can write this one as what? Joule by mole into Kelvin. Okay. So you can sometimes you can write as joule mole inverse Kelvin inverse. Okay. So universal gas constant. So in this SI unity you can take its value is 25 by 3 or 8.314 like that you can take, and if I want to write dimension, then definitely I need to convert this is joule as kg meter square second to the power minus 2 into mole inverse Kelvin inverse. So now if I want to write dimension of this gas constant R, so how much will come here? It will be coming m to the power 1 because kg to the power 1 is there, L to the power 2 because meter to the power 2, then after second to the power minus 2, so it is T to the power minus 2, then it is mole to the power minus 1 and Kelvin to the power minus 1. So this will be your dimensional formula for gas constant. Okay, so universal gas constant, remember it is R PV by NT or joule by mole into Kelvin. Okay, now I will go to the next quantity, that is (45), that is your coefficient of thermal conductivity. Now what is this one, coefficient of thermal conductivity? Now here remember, whenever one rod is there, in this rod when you are providing one heat, okay, and here some length will be there L, and here some temperature difference will be there T1 and T2 like this, and here this is the area of cross section of this rod, and you are giving a heat, and here time suppose taken T, then what I can write? I can write heat flow. So this heat energy flowing is basically depends on what? It will be directly proportional to area of cross section and directly proportional to the temperature difference. Okay, suppose here T1 T2, so T1 minus T2 temperature difference it will depend, okay, at the end of the rod, and it depends on the time also directly and inversely proportional to the length. Now from here if you want to find Q, that will be a proportionally constant K, you can write A delta T small t by L. So delta T is remember temperature difference and T is basically time, L is the length. Now from here this K is called basically what? Now coefficient of thermal conductivity. So that is nothing but Q times L divided by A times delta T into small t. So you can write like this way. Now here see, so here I can write the unit immediately. So Q is nothing but heat basically, remember heat and work both having same unit or dimension. So I can write it is joule, and this L is nothing but meter, A is nothing but meter square, and T is nothing but Kelvin, and this will be second. Okay. Now here one more thing also you can do. So here you can write a joule by second is nothing but how much? Now that is your watt. So you can write it is watt, okay, into, so here a meter inverse, because this one will go up, it will be meter inverse, and Kelvin inverse. So this way also you can write your what? Now here K. Now here remember this K is different. So here this K is Kelvin, this K is basically a coefficient of thermal conductivity. Or if you want to little modify, you can modify also. So joule is nothing but that is kg meter square second to the power minus 2. Now this meter square getting cancelled. So here down will be meter K Kelvin second. Now here you can cancel. So meter will cancel to meter square. This meter will cancel to this meter square. Now this second will come up, it will become second to the power minus 3. So I can write this one as kg meter second to the power minus 3 Kelvin to the power minus 1. Now from here if you want to write the dimensional formula for thermal conductivity, that is how much? M to the power 1, L to the power 1, T to the power minus 3 and K to the power minus 1. Okay. So remember here this K and this K difference is there, this is your temperature. Okay, sometimes you can tell theta also, theta to the power minus 1, but this is your thermal conductivity, coefficient of thermal conductivity. So this is a difference coming. Okay, so you remember the formula for the heat or thermal conductivity, okay, coefficient of thermal conductivity, then easily you can easily you can find from the SI unity, then after you can find the dimension. Okay. So remember always when heat flowing is happening, it depends on the area also. So if a more wider rod is there, then heat will flow more. So that's what is directly proportional. It depends on the temperature difference between 2 points. So that's why directly proportional to the temperature also, and time also. If more time will heat, then more heat will go to that rod. So that's why it depends on the time directly. But remember, if length will keep a long rod, then what will happen? Heat will take that heat energy will take a time to reach from one point to another point. So flow will become basically less. So that's why it is inversely proportional to length. So then after you are finding here a proportionality constant K, that is called coefficient of thermal conductivity. Okay. I will go to the next quantity. So remember, sometimes they can ask this unity, this dimension or this unity can be asked also, and sometimes this also can be asked. And remember, joule by second is nothing but already studied, that is your watt. So that's why in this place we are putting watt. Now come to the next thing, that is 46. So here we will understand entropy. So what is entropy? Entropy formula is basically S, that is nothing but heat, change in heat by absolute temperature T. So here I can write this one. So this is nothing but joule. So joule by Kelvin. Okay. Or I can write also, it is nothing but kg meter square second to the power minus 2 Kelvin to the power minus 1. Or here you want to write the dimension of entropy. Entropy symbol sometimes given S, or you can write delta S also, change in entropy. Now here it is nothing but M1 L2 T minus 2 K to the power minus 1. So it is simple only. So here entropy dimension you are understanding. So for everything you need formula. Once you understand formula perfectly, then after you can find the dimension and its SI unity also. Now we will go to understand some different some formula and its some constant unity or its dimension also, and some other important dimension and physical quantities also. Okay. Now come to here. So here suppose I am telling Newton's law of gravitation. Suppose here we will understand what. Now here Newton's law of gravitation. So that is what basically. Now if two masses are separated by distance r, then after what happens? Now the gravitational force between them is nothing but g times m1 m2 by r square. That means universal gravitational constant times product of the masses by distance square. So here mass m1, here mass m2 separated by distance how much? R. Now here I can write this one as how much? Now g, if I want to calculate, I can write g as fg into r square divided by m1 into m2. So I am calculating this g basically. So what is this g? Now this is g is called universal gravitational constant. Okay. So here sometimes they can ask what is the SI unit of g or what is the dimension of g. So that time what I will do here, this implies g unit is nothing but f unit is Newton, distance square means meter square, and m1 m2 means it is kg into kg, which is kg square. This one also can be written as Newton is nothing but kg into meter second to the power minus 2 into meter square divided by kg square. Now from here you can write, so here what you can write, now kg will cancel to this square, this kg will go off, so it will become kg to the power minus 1, meter to the power 3 and second to the power minus 2. So this is your unit also you can remember, or this unit also you can remember for g. Now here if you want to write what is the dimension of g, now dimension of g is nothing but, see this unity, now here mass to the power minus 1, m minus 1 and m to the power and m to the power 3, so you can write L to the power 3, then T to the power minus 2. So this is your universal gravitational constant dimension. Okay. So once you know formula, then easily you can find it here. Okay. So Newton is nothing but kg into meter second to the power minus 2, meter square will be there divided by kg square. So here some cancellation will happen and answer will getting this one. Okay. So here this is the idea about g. Now similarly some other quantity will understand. Now let me go for, so this is called epsilon naught and another thing is called epsilon and another thing is there epsilon r. So epsilon r is called basically permittivity of free space, or this epsilon is called permittivity of a medium. So when you study electrical property, that time you will understand this material property basically. So epsilon naught, epsilon, and this is called dielectric constant. Okay, epsilon r is called dielectric constant, and it is having no unity or no dimension, because this epsilon r can be written as epsilon by epsilon naught. Okay, so this is the permittivity of any medium, suppose water medium, take metal medium, like that type of things, but this is your free space. So both will having same unity. So when this you are dividing, you are getting dielectric constant, or sometimes this is called also a relative permittivity. Relative permittivity. Relative permittivity. So that, sir, your dimension is how much? Dimension is 0. So this one you remember. Now the next thing understand about this epsilon naught little. So here if epsilon naught and mu naught, root I will take and reciprocal I will take, then this will give you speed of light. This will give what? Speed of light. Permeability of free space. Remember what is this? Permeability of free space. Okay. So permeability of free space. So the speed of light, so its unit is nothing but meter by second. That means sometimes if they ask what is the unit of this 1 by epsilon mu naught root, okay, 1 by root under epsilon mu naught unity, then it is basically speed of light. Now also this can be written as mu naught epsilon naught to the power minus 1 by 2. Okay, so here it is a root is there, so you can write also minus 1 by 2. Okay, because this root will go up means it will become minus half. That's all. If I want to write, that means I am to write dimension of mu naught epsilon naught, then it will be how much? Now this is nothing but m0 L1 t to the power minus 1. Okay, because it is what coming? Now this thing is coming speed of light, which is basically speed unity meter per second, or L1 t to the power minus 1. Or sometimes you can understand also, if you write c square, then c square is nothing but mu naught epsilon naught. So this, that is your c square. Okay. So 1 by mu naught epsilon dimension, if they ask, then it is what coming? It is coming here meter square by second square, or you can write here 1 by mu naught epsilon naught dimension. If you ask, then it will be nothing but m0 L2 t to the power minus 2. So in exam you have to check properly, they asked 1 by root under mu naught epsilon naught, or only this one, or 1 by mu naught epsilon naught only this one. So accordingly you have to check answer. Okay. So this dimension also this one m0 L1 t to the power minus 1. Okay, because this is nothing but mu naught epsilon naught to the power minus half. Okay. So this is all idea about some certain formula. There are many things are there. There are many constants there. There are many quantities are there. So when we will be studying the lecture, that time we will be understanding different quantities. So whatever most important quantities and its constant value, or its SI unit and dimension, we are understanding here. Okay. Now write here also, let's say SI unit will be nothing but meter by second. Okay, this unit SI unit is meter by second, and this unit SI unit is how much? Now this SI unit is nothing but, it is your meter square by second square, because speed is square. So see the speed of light, so speed square means meter square by second square. Okay. So this is all idea about today's lecture. Now we will be solving some MCQ based on whatever quantities we discussed. Okay. And remember there are many electrical quantities are there in 12th standard will study. Suppose I am telling here this R is called basically resistance, and this C is called basically capacitance. And if you multiply this R and C, then what they will give you? Now they will give you basically time, or it is basically called time constant, or basically it is what? Now RC, SI unit how much? SI unit is time. Okay, SI unit is basically time unity, which is nothing but that is second or time unity, or dimension if you want to write RC, that is nothing but m0 L0 t to the power 1, because RC is nothing but represents time. So time means t to the power 1 unity. So that means RC unity or dimension is exactly equal to what? Time, and R remember resistance, and C is basically capacitance. When electrical circuits will study, that time we will understand what is resistance and capacitance. So here also you can write as L by R unity or dimension is exactly equal to time unity, or you can write also root under LC. Okay, root under LC unity also equal to what? Time unity or a time dimension. Okay, root under LC, remember. So this is the most of the idea we understood from the this one, that formula and some constant. Now we will be solving some MCQ based on this. Now move to the some MCQ questions here. Now see here, the first question is given in NEET 2019. The unity of thermal conductivity is what? So here options are given. Just now we discussed. So what is the unit of thermal conductivity? Now thermal conductivity is nothing but Q into length divided by area into temperature difference into time. So this is your what? This is your coefficient of thermal conductivity. Now here you can write what? Now this Q is nothing but that is your joule, L is nothing but meter, A is nothing but meter square, delta T is nothing but that is your Kelvin, T is nothing but second. Now joule by second you can convert it to what? Watt, because here see all options are given in watt and all. So W stands for basically watt. So I can write here this is nothing but watt, and here meter will cancel to meter square, meter will come up, it is meter to the power minus 1, Kelvin to the power minus 1. So here this is exactly matching with option A. So your answer will be what? Option A. So thermal conductivity, just now we discussed in the previous slides that thermal conductivity or coefficient of thermal conductivity unit is what basically? Now watt meter to the power minus 1 and Kelvin to the power minus 1. So option A. Now we will go to the next question. Now here they are asking the unit of permittivity of free space, that is epsilon naught, is how much? Okay, this is also a previous year NEET question. Now here they are telling some coulomb, Newton, meter, coulomb, square meter, Newton, like that type of some options are given. Okay, you remember electrostatics force formula 1 by 4 pi epsilon naught Q1 Q2 by R square, Q1 Q2 by R square. Now remember here, so this is called basically epsilon naught, and this is your Q1 Q2 the charge. Now here epsilon naught if you want to find, then what is it is? That is your Q1 Q2 by 4 pi Fe R square. Now Q1 Q2 two charges, so its unit is what basically? Its unit is coulomb into coulomb, coulomb square by Newton into meter square. Okay, so here unity of epsilon naught is how much? Now coulomb square Newton into meter square. So it is exactly matching with option C. So coulomb square by Newton into meter square, or it is the unity which is reciprocal of what? 1 by 4 pi epsilon naught unity. Okay, so that also you can understand. I will go to the next question. So here option C will be a correct answer. The dimension of mu naught epsilon naught to the power minus half are how much? So now listen here, it is given a NEET 2011 and 2012 they asked also. Now here just now I told, so C is nothing but speed of light, which is nothing but mu naught epsilon naught, and root will be there, and 1 by root under mu naught epsilon naught, that is your C. Now this is what? This is your speed of light. So what is speed unity? Now speed unity you know. So speed unit is nothing but meter per second. So that's why its dimension will be L to the power 1 by T to the power 1, which can be written as m0 L1 T to the power minus 1. Okay, or only you can write L1 T to the power minus 1, which is the dimension of this quantity, or this quantity can be also written as mu naught epsilon to the power minus half. Okay, because it is in the down, root under is in the down, when it will come up, it will become minus half. That is what they are asking here. So that's why your answer will be what? Option C, that is L1 T to the power minus 1. Okay, so I hope you understand. So this formula remember, and you calculate what is your dimensional of the physical quantity. Now here they are telling, according to Newton, the viscous force acting between liquid layers of area A and velocity gradient is del V by del Z. Okay. Now here they are telling given by how much, this force is given by minus eta. So this is eta basically, that is you can tell directly coefficient of viscosity actually. So A delta V by delta Z. Now they are asking the dimensional formula of eta is how much. Already I discussed what is the dimensional formula of eta. So if you know or you can remember, then you can directly tell answer here. Okay, definitely I remember here, this answer will be D option. Okay, but think remember from here also you can calculate. If a formula they have given means you understand they are making your path easy to find it out the dimension. Now what you can do? Now you can write here eta, how much it is? Force by area. So this area will come this side. Delta Z will go to the force side, then it will become delta V. Now also here you can write it is Newton by meter square into delta Z is meter. So remember delta X, delta Y, delta Z, delta L, all unit will be meter. Now this one you can write as meter by second. Now here you can calculate this one. So Newton also you know, you can calculate this meter cancel. Newton is nothing but kg into meter into second to the power minus 2 divided by meter square into second to the power minus 1, because 1 by second it is second to the power minus 1, this will go up actually. Now here also you can write directly what? Now meter square cancel, you can write here kg meter to the power minus 1 second to the power also minus 1, because this one will go up means it will become plus. So second to the minus 2 plus 1 it is minus 1 only, so second to the power minus 1 coming. That means if a dimensional formula I have to write for eta, then how much it is? M1 L minus 1 T minus 1. Okay, because it is coming kg to the power 1, meter to the power minus 1 and second to the power minus 1, that's why M to the power 1, L to the power minus 1, T to the power minus 1. I will go to the next question. Okay, I hope you understand. And here they gave a formula so that you no need to remember the dimension. Directly from the formula you can calculate like this, and you must remember when velocity gradient is given, or directly you can write it is nothing but second unit. Okay, so directly you can write also. So force is nothing but kg into meter second to the power minus 2 into second divided by meter square. Also you can get the same answer. Now we will go to the next question. The dimension of RC is how much? Square of time, square of inverse of time, time inverse time. Now remember here 4 options are given. Just now I told R is basically resistance and C is the capacitance, and its unit is what basically if we will multiply it will be exactly equal to time. Okay, so later we will see what is R and C while studying electrical circuits. So here your unit will be nothing but time. Okay, not only R and C, but also if you will take L by R. Okay, so in inductance L by R also same, and also you can write root under LC, that is also same unity, that is basically time. Okay, so root under LC. Now I will go to the next question. So here it is easy question only. So RC dimension is nothing but that is equal to time. Now which of the two of the following 5 physical quantities or parameters have same dimensions? Okay, now you see here 5 parameters are given and options are given in the down. So they are asking which are having same dimension. So first quantity is energy density. So you know energy density means what basically it is your energy by volume, energy by volume. And refractive index, so refractive index is what basically? Now refractive index sometimes you can give n or mu, that is nothing but speed of light in air or vacuum divided by speed of light in any medium. So that is just speed by speed. Definitely this dimension if you will calculate, it will be m0 l0 t0. So dimension of refractive index is what? m0 l0 t0. Now dielectric constant, so dielectric constant just now I defined, that is epsilon r, that is epsilon by epsilon naught, and if you will understand here this is also not having dimension or unity, so it is m0 l0 t to the power 0. Now Young's modulus already you know, Young's modulus is basically y, which is basically force by area, so that you can write as Newton by meter square, or you can tell basically it is Pascal. Okay, that's unity. Or a dimension if you want to write, so dimension is nothing but m1 L to the power minus 1 T to the power minus 2. Okay, so this also you can write, because Newton is kg into meter into second to the power minus 2, and down meter square it will go up, it will become L to the power minus 1. Okay, now here energy density will check now energy density. So energy density means energy by volume. So it is energy dimension is m1L2 T minus 2 divided by L to the power 3. So when L3 will go up, it will become m1 L to the power minus 1 and T to the power minus 2. So definitely what is happening here? Now these two dimensions are same and these two dimensions are also same. Now we need to check with options. Before that you understand about magnetic field. So magnetic field is basically B symbol. Okay. So later we will study what is electric field and magnetic field. Remember E basically written as electric field, B is called basically magnetic field. So here B is what? Now B you can calculate basically force by charge into velocity. Okay, force by charge into velocity. So definitely here charge is there means ampere and second will come. So definitely here this ampere will come. So this will be not mismatching actually with everyone. So it will not match with anyone here because ampere will come here. So that's why I am not including this one. Now I am checking with this 4, first 4. So I can tell my 1 and 4 are matching and my 2 and 3 are matching. Now check option. So first option itself telling 1 and 4 and there is no option 2 and 3. So definitely my option A will be correct. Okay. So remember physical quantities, then after easily you can find what is the dimension or what is the question asking. And magnetic field why I omitted because your charge is there. So due to that one ampere will come. So that base quantity or SI quantity, fundamental quantity will come. So here that's why what will happen, ampere will not match with anyone, so we will not consider here. So that's why this for considering energy density Young's modulus is exactly same and refractive index dielectric constant is exactly same, but these 2 and 3 options are not mentioned in the option 2 and 3 answer. That's why we are considering as 1 and 4. So this 1 and 4 are matching exactly. Okay. So I hope you are understanding this question. Now we will go to the next question here. Telling the dimension of half epsilon naught E square where E naught is permittivity of free space and E is basically electric field. Okay. So electric field we did not study. Remember electric field is nothing but that is your force by charge. We did not study, later we will check this one in electrostatics. At the force by charge, or you can write basically it is Newton by Coulomb, Newton by Coulomb electric field. So Newton by ampere into second, this one you can do. So this is the electric field unity. Now remember here epsilon naught unit already you know, epsilon is what? Now epsilon unit is nothing but that is your Coulomb square by Newton into meter square. So this one already know epsilon naught unity, just now we have calculated. Now if this what will take E square will take and epsilon naught will multiply, then you will get some dimension or quantity. Already everything you know here, so you will get some quantity here. Okay, any Coulomb also nothing but Coulomb what you can do, it can ampere square into second square by Newton into meter square. Okay, so you can multiply, you can check, but here one easy formula I am telling to calculate. Remember this quantity is basically represent what you know, this represent energy density. So here energy density already we know, energy density means what, that is definitely energy by volume. So m1 L2 T minus 2 by L to the power 3. So this one, now here 3 will go up, it will become 2 minus 3 which is L to the power minus 1. So I can write here m1 L minus 1 T minus 2. So this will be answer. So you check here option B is exactly matching m1 L minus 1 T to the power minus 2. Okay, these options are not matching here. So B is matching exactly with here this formula energy by volume. Or you can do this one, if you will do this also half epsilon naught E square, the same thing will get. Okay, same thing will get, you can check once. Okay, here definitely if it's E square will take ampere square will come, here ampere square already there, so they will get cancelled. Okay, it is in the down, that is in the up. So this is what we are understanding here. So once you know the formula, concept and the SI unity, then easily you can find the dimension and dimension related questions. And whatever questions we have watching here, this all are previous year questions. So easily you can solve once you are understanding and remembering formula and SI unity. Okay. So that's all for today lecture. Now we will be discussing more concepts and problems on the units and measurement and particularly dimensions also. Keep watching the video, like and subscribe Vidhyalakshmi NEET Academy YouTube channel. We will be uploading more videos on this. Thanks for watching. All the very best.